All right, welcome to applications of logarithms, because why should we study anything that we can't apply to stuff? So make sure to write your name up here. Peter. Anyway, so let's look at some applications of logarithms. Let's say that you have a pendulum next to a motion sensor. Let's say you have the greatest distance away from the sensor is modeled with the equation y equals 1.25 plus 0.72 times 0.954 to the x minus 10. So this is an exponential equation, and it's an exponential decay equation. Decay, right? Because it's getting less and less each time. As it swings, it's not going to go out quite as far each time, right? And it'll kind of come down close to zero, but never, in theory, equal zero. And if we look at our b, we can see that the percent change, it goes down by, well, let's see, 0.954 minus 1 equals 0.640. So in other words, it goes down by 4.6% each swing. Use this equation to find the swing number when the greatest distance was closest to 1.47. Now this goes back to people asking me, how do I solve for y given different problems? I would tell you, well, just look on your calculator. Well, this is finally when we get to do that. So the first thing we're going to do is we're going to take our equation, right, and we're going to plug in that 1.47 and get ready to substitute in, well, we'd substitute in 1.47 for y, okay? Next step I'm going to do is I'm going to look on this side of the equation. Let's rewrite it here. 1.47 equals 1.25 plus 0.72 to the 0.954 x minus 10. I'm going to subtract this 1.25. Okay, and I'm going to get, let's see, what's that going to leave me with? 0.22 equals 0.72, 0.954 x minus 10. My next outermost function is this times 0.72. So I'm going to divide by 0.72. So 0.22 divided by 0.72. Let me go to my calculator and figure that out. All right. So now I'm going to go in here and say 0.22 divided by 0.72 equals 0.305555556. Okay, here we go. So we'll switch back over. 0.30556 equals 0.954 to the x minus 10. Now all of a sudden we've got that exponent up in that x in that exponent spot. And this looks kind of confusing, so I'm going to switch to log form. So there's my base, so I'm going to say log base 0.954 of, there's my argument, 0.30556 equals x minus 10. So my next step is going to be, well, I can use that change of base formula to rewrite this. So I'll say the log of 0.30556. Let me write that out. Change of base. And divided by the log of 0.954 will give me x minus 10. So then I go back into my calculator and remember those numbers. And actually, I could say log of the answer divided by log of my base, which was 0.954. And that'll give me an answer. 25.177. Go back to my thing. And then I'm going to get 25.18 equals x minus 10. And then my last step is just to add 10 to both sides. And I get my answer, 35.18. 35.18 what? Let's go back up, see what that is. So this equation tells me the rate at which swings. So find the swing number when the greatest distance will be closest. So a little bit after, so it will be closest at 35 swings. It will be less than that at 36 swings. Okay. So that's our first application. But basically, you can see where we use logs whenever there was a variable in that exponent spot, and we've kind of solved down. That's when we are going to switch to logs, switch to log form. Let's look at the next problem. Example B, you open a savings bank account with $1,200 and earn 3% annually, but it's compounded monthly. How many months will it take to double your money? What will your start amount be? Well, it'll be $1,200. You have 3% annually. What percent do you earn monthly? Well, if I get 3% annually, let's divide that by 12, and I get that amount. 0.03 divided by 12, I get 0.0025. Let's go back up here. 0.0025 or 0.25%. What type of function is it? Anything that grows by percents is an exponential function. Write the equation. Y equals, so we'll use this form. Y equals A times B, or A times 1 plus R to the X. Okay, so that will be Y equals 1,200 times 1 plus my monthly percentage is 0.0025, so I can say 1.0025 to the X. And X being the number of months. Okay? How much is double? Well, that would be $2,400. So let's solve it down. So how many months will it take you to double your money? So I'm going to say 2,400 because that's my amount of money. I'm replacing Y with that. Equals 1,200 times 1.0025 to the X. All right, now I'm going to solve down. First thing I'm going to do, divide by 1,200. And I'm always going to get 2 equals 1.0025 to the X. I've got that X in that variable spot, so I'm going to switch to log form. Okay, so I'm going to say log of log base 10025 of 2 equals X. Now I can use my change of base form. Log of 2 over the log of 0.0025 equals X. Plug that into my calculator. Clear. Log 2 divided by log 1.0025 equals that number 277.6. We're down here. Equals 277.6 equals X. Well, how long is that? 277 divided by 12. Let's see. Divided by 12. So that would take approximately 23 years. So 23 years, or 23 years, approximately. All right, well, I'm going to save this up to, and we'll go to the second one.